Hello, Laideson. I hope I've pronounced your name correctly. Is that your name? Is that how it's pronounced? Can you hear me? Okay, let's continue. So we were doing lists. So a list looks like this. This is how a list looks like. It has numbers. Okay, it can contain numbers. Like this is a list of numbers, as you can see here. It consists, this is a list consisting of 5 values and all of them are numbers. So this list consists of 5 values and all the 5 values are numbers. The elements inside a list may be of different types. The elements inside a list do not have to be of the same types. We can have integers, floats, strings in the same list. Python lists are always numbered from 0. So here it is 0, 1, 2, 3, 4. So if you start numbering a list or if you start indexing a list, you always start from 0. So our list is a collection of elements, but each element is scalar. So a list is a collection of elements. Okay. Now, this is a practical on printing lists. As you can see, when we have run this, we have just printed numbers. The list stored in the variable numbers, and it has printed for us the list as shown here. So we can assign a new value to the first element of the list. So if you want to assign a new value to the first element of the list, you do this. You write the list name, the index, and then what you want to assign, the number you want to assign. Let's run this and see. As you can see here, the first element of the list has changed from 10 to an 11 because we have assigned it here. So this is how you assign a value to a certain index when it comes to the list. If you want to assign another a value to, let's say, the second element of the list, you change this to 1. Let's run. As you can see, it has changed. The 111 is now on the second element. So that is just basically how you assign values to a list. It is known as indexing. What we have done here, assigning values to a list, is known as indexing. Accessing list contents. For example, you want to access a certain element in a list. You can access it using its index. For example, here we want to access the whole list, so we use numbers, the name of the list. Here we want to assign the number 111 to the first element of the list, so we use indexing. And then here we want to assign the fourth element of the list to the second element of the list. Okay, the fifth element in the list to the second element of the list. And then now if you want to get the length of the list, you use this keyword called len. So if you want to know how many things are in the list, or how, for example, let's take our list here. If you want to know how many numbers are contained in the list, we use this len keyword, and then the brackets, and then the name of the list. Let's run it and see. Okay, so as you can see here, we have assigned 111 to the list. Here we have also assigned the last element to the second element in the list to be the second element in the list. So the one of the last element is also now 1. As you can see, the second element was 5 before we assigned it the last element of the list. And then when we assigned it the last element of the list, it changed to 1. And here we are told the list length is 5. So that means our list contains 5 things. Okay, removing elements from a list. Any of the list elements may be removed at any time. So for example, you want to delete an element from a list. You use this del keyword. The del keyword is used to delete something from a list. For example, you want to delete the second element of a list. This example here, when you want to delete the second element of the list, so you use del numbers 1. You index to refer to the element you want to delete. So here we want to delete the second element. When we run this, the list will have a length of 4. Let's run it and see. As you see here, the new length is 4. The list length was 5, but after deleting, the new length is 4. This is the code for deleting. As you can see, this is the del keyword, and then the name of the list with the index of the number you want to delete. So you can also use negative indices to index or to refer to values in your list. For example, here -1. This -1 shows the last element of the list. And when you say -2, it goes to the second last element of the list. So as the negative go further, also the elements, you are moving up the elements of the list. For example, this 1 is -1. Sorry, this 1 is -1, this 2 is -2, this 7 is -3, this one 11 is -4. Let us run and see. As you can see, this -1 has given us the last element of the list, and then this -2 has given us the second last element of the list. So that is how negating works. It is the opposite of a positive index. So if you use a negative index, you will move the opposite. You will move in the opposite direction compared to a positive index. A positive index moves from left to right, but a negative index moves from right to left when it comes to displaying values. Like -1 is 1, -2 is 2, -3 is 7, -4 is 111. This is a lab. I will not do the labs for you. You have to do the labs for yourself so that you understand. And so far, no one has sent me a screenshot of their labs. So I don't know what you expect me. I don't know if you expect me to do it for you, but you have to do the labs for yourself. I will only be doing the examples, but when it comes to the labs, you will be doing them for yourself. I cannot do the labs for you. Okay. So before we move on, have you understood about lists? People in the class, Faith, Laedeson, okay. Laedeson, have you understood about the lists? Can you hear me? Hello, is there anyone there who can hear me? Okay, if you can't talk, just type in the chat. Have you understood about the lists? Okay. Okay. You aren't late. Okay, fine. So if you've understood, I will urge you to also go through them yourself so that you understand.
Hi, Yvonne. I don't know if my network is the problem because your voice keeps breaking.
Oh, Lydison, can you get me clearly? Okay, let me check. Can you get me clearly? You can type in the chat. I will see. I'm sorry about that. I just changed my network. Can you get me clearly now? Faith, can you hear me? Am I clear? I am trying to see if my network is okay. Kindly talk to me. Can you hear me?
Yeah, I can hear you now.
Okay. So sorry about that. I have changed my network. I hope this one won't give me issues. Okay, let's continue. Functions and method. A method is a specific kind of function. So there are functions and there are methods. So a method can be a function, but a function cannot be a method. So a method is a specific kind of function. It behaves like a function, looks like a function, but differs in the way in which it acts and in its invocation style. So that is the definition of a method. It acts like a function, it behaves like a function, but it differs in the way it is invoked and in the way it acts. A function doesn't belong to any data. It gets its data, it may create new data, and it produces a result. So a function doesn't belong to any data. What a function does is it gets data, it may create new data, and it produces a result. For example, you create a function to add two numbers. It gets a data in that you feed it the two numbers, and then it creates new data in that it may add to create the new data. For example, a function that adds two numbers, and then you give it 2 + 2. That is it getting the data. When it gives you when it creates 4, that is it creating new data, and then producing a result. When it tells you 2 + 2 is equals to 4, that is it producing a result. A method does all these things, but is also able to change the state of a selected entity. If you call a method on an entity, it can change the state of the selected entity. We will see that as we move on. You will see how it can change the state of a selected entity. A method is owned by the data it works for, while a function is owned by the whole code. So a method is owned by the data it works for. You can't, when a method is owned where it is applied, we'll see how a method works. You will understand this more and more when you know how a method works. While a function is owned by the whole code. A function is owned by the whole code in that you can call a function anywhere after defining it. After defining it, you can call that function anywhere in the code after defining it. But a method only works in the data where it is called. In the place where it is called, that is where a method only works. It is owned, a method is owned by the data it works for. It is owned by the data, not by the code. We will understand more and more as we move on. This also means that invoking a method requires some specification of the data which the method is invoked. It may sound puzzling here, but we'll deal with it in depth when we delve into object-oriented programming. Okay. Methods are also found in OOP. In general, a typical function invocation may look like this. So this is how you invoke a function. This is the way you call a function. The function and then the arguments of the function. If the function takes arguments, if it does not take any arguments, this arg will be missing. It will only be a function and empty brackets. The function takes an argument, does something, and then returns the results. A method invocation looks like this. Now, this is how you invoke a method. As you can see, it is almost similar to the function, but here now, you use data.method. This is how you invoke a method. Note, the name method is preceded by the name of the data which owns the method. Next, you add a dot followed by the method name and a pair of parentheses enclosing the arguments. This method will behave like a function, but it can do something more. It can change the internal state of the data from which it is invoked. So as you can see here, when you call a method, you first start with the name of the data, which you are calling that method from, or the data in which you want that method to change, and then there is a dot, then the name of the method, and then the arguments that the method takes, if there is any. So, for example, you want to insert something in a list. As we have said, methods change the state of the list. Methods can change the state of the data. For example, here, our list is the data. Append is the method. And append, by the way, is used to add an element to the list. This is another way of adding an element to an existing list. So we have said one, if you want, this is a way of adding an element to a list. We have said that if you want to change the elements of a list, you can use indexing. But if you want to add the elements in a list, you can use append. And append adds values to the end of the list. For example, here, we have our list numbers. You remember numbers, the list we used in the beginning? So this is the list. We have our list numbers, and it has 4 numbers, 111, 7, 2, and 1. We want to add 4. So if we use numbers.append and then we run, this 4 will be added here after 1. This 4 will be added after 1 at the end of the list. And then there's also another method, insert. So there are 2 elements. There are 2 methods that are used to add elements in a list. There is append, which adds elements at the end of the list, and then there is insert. In insert, it takes the argument, location, and the value. Sorry, I have forgotten to mention that append takes the argument's value, the value in which you want. For example, we can say the value here is 4, like here. The number which you want to add at the end of the list, that is the value it takes. So that is its arguments. Here, insert takes 2 arguments, the location in which you want the value to be inserted, and then the value itself. For example, here we want to insert number 222 at the index 0 or at the start of the list. So we use insert, and then we first start with the location where we want the number to be. Here it is 0. We want it to be the first number, and then the value of the number, which is 222. Let us run and see. Sorry, a bit. As you can see here, the initial list before adding anything had 4 numbers, which was 1, 1, 1, 7, 2, and 1. After appending 4, as you can see, this 4 has been added at the end of the list here. And the list contains 5 elements. And then after inserting 2, we inserted 2 at the very beginning of the, we inserted 222, sorry, at the very beginning of the list. So here it is at the very beginning of the list, and now the list has 6 elements. So these are examples of of methods. As you can see, the method has changed how the data looks like. The method has changed how the list looked like. It has increased the values in the list. Before we move on, have you understood? Kindly tell me if there's any question before we move on. Okay, let's continue. You can start a list life by making it empty. Okay, so for example, you can have an empty list without anything, like here. This is an empty list where you have only this, sorry, where you have only this type, these brackets. Okay, and then now you can use a for loop to append things in the list. For example, here, we are appending numbers from 1 to 4. For I in range 5, my list.append I plus 1. So you are appending numbers here. We are appending 5 numbers in the list, and we are starting